temperature of 1. This is the temperature of 2. Why we are about to learn this thing? Because this is the concept of mixing. I have already told the mix. If we do mixing before conditioning, we will get low power. We will get high performance at the cost of low power consumption. Suppose say I already told 50% of outside air is exhausted from the room and 50% is mixes with the fresh air. Suppose this is the outside air 1, this is the room, this is state 2, this is our AC. When first time outside air come in contact with AC, this is conditioned and goes to the room. After that, the conditioned air is leaving from the room and goes to the outside. If we want to recirculate some air, outside air or used air, then we will get low power consumption. Suppose this is 40 degree temperature summer air conditioning. A room temperature in India or Asian country, we always remain at 25 degree or 26 degree and 50% relative humidity or 60% relative humidity. Always this is standard as per the ASHRAE. In Asian countries, this is standard value. Suppose outside air is 40 degree summer air conditioning and room maintain is 25 degree and 50% relative humidity. So air leaving from the room is also 25 degree. This is state 2. We want to reduce our power consumption because the electricity bill goes on increasing. So we want to use this type of process, adiabatic mixing. Suppose when first time is processed, then when it is circulated from the room, we want to take 50% of used air. 50% of used air mixes with fresh air, which is have 40 degree temperature. State 1 is 40 degree temperature and fresh air, and 25 degree temperature air is used air, which is we want to use 50% with the fresh air. So before processing, we use a mixing. So before AC, 50% of outside air and 50% of used air mixes to all together, and we will get 100% of air before AC. After that, it is conditioned to and then supplied to the room. So what will happen? First time, when you use 40% 40 degree air, outside air to the AC, then what is the temperature difference? 40 degree to 25 degree. The capacity of AC is mCp dt. Mass of air Cp of air and dt. So these are the constant value. This is the capacity of AC. When the temperature difference is more, then the capacity of AC is also more. So the cost will be very high. So first time AC condition 40 degrees outside air to 25 degrees. This is our first time cause. Then we want to use 50% of used air and 40% of 40 degree and 50% of fresh air. Then what will happen? 50% of what is the state of air after mixing before conditioning? Now calculate this. 40 degree of 50% means 0.5 plus 25 degree into 0.5. What will get? 40 degree 20 plus 25 12.5. That is 32.5. 32.5. 32.5 degree. Now before AC it is available at 32.5 degree. Before AC it is at 32 degree, or to the room it is always remains same 25 degree and 50%. So the capacity of AC here for mCp dt, a mass constant, Cp constant, particular air, Q is a function of dt, is temperature difference. The first case is the difference is 40 degree to 25 degree, difference is 15 degree. Our second case is after mixing, after we using mixing process, the capacity is temperature difference is 25 minus 32.5. 25 minus 32, that means 7.5. The temperature difference is 7.5. So we required lower tonnage of AC because the AC always want to reduce the 7.5 degree compared to 15 degree. So the capacity or tonnage of AC is less here. For same type of condition, summer air conditioning 40 degree. The room is 25 degree. If we use mixing, then AC, low tonnage of AC is doing so. So our power consumption is also less. That is why mixing is required. This is the significance of adiabatic mixing of two streams. I hope you will understand all those things. If you have any query about this topic, then ask me or WhatsApp me. Thank you.